So the next part to talk about with limits are one-sided limits. So whenever we were looking at limits before, I kind of talked about approaching from two different sides. So those are the two sides that we're going to talk about with limits. So there's the left-handed limit, and that's going to be approaching from the left. Then there's the right-handed limit, and that's going to be approaching from the right. So what is the notation of this? Well, there are two. There's the left-handed limit, and we notate this the same way. So it's the limit as x approaches c, but instead of just having it like we had before, we put this little negative here. So this means we approach it from the left. Still put f of x here, and we still say it's some number L. So that's the left-handed limit. We say f of x, the limit as x approaches c from the left, so from the negative side, of f of x is equal to L. We also have our right-handed limit. Here we still have the limit as x approaches c, but instead of putting a negative for the left-hand side, we put a plus, meaning we're coming from the right. Still the f of x here is equal to L. So that's our left-handed limit. We're approaching from the left. Here's our right-handed limit approaching from the right. So let's look at an example. So the example that we're going to look at is our function 2x that we've been looking at. So here's my function, f of x equals 2x. So let's write that. So the first example is where f of x equals 2x. What's happening as x approaches 5 from the right? So here's the point where x equals 5, my y value here is 10. What's happening as I approach 5 from the right? So here's from the right, so I'm moving. What are my y values doing? They're decreasing to 10. So we would say, in our example, we would say that the limit as x approaches 5 from the right, so x approaches 5 and I have a plus sign meaning from the right, of the function 2x, which is what we were just looking at, was 10. Now what is it from the left? So let's go back. Here's 5, I'm approaching it from the left, so I'm going to start over here. What's happening to my y values? So I'm moving and they increase to 10. So we would say that also the limit as x approaches 5 from the left, so with a negative sign as the exponent of my function 2x, is also 10. So that's our first example. Now let's go to this piecewise function that I have. So a piecewise function is where I define two different parts, so you can see the two different pieces here. I have my first piece and I have my second piece. Let's talk about the limit as x approaches 2 from the right. So the second example is my piecewise function. And let's first look at the limit as x approaches 2 from the right. So I'm looking at this of f of x. So what is that equal to? So go back to my graph. Here's 2. Here's the point where x is corresponding to 2. As I approach it from the right, so I'm over here, these are my x values. Look on the curve that's to the right of 2. What are my y values doing as I approach the point at 2? Well, they're staying constant at -1. So we would say that the limit from the right is equal to -1. So to answer this question, we would say -1. Now what about the limit as x approaches 2 from the left of my function that I have on the screen? So what is that equal to? So the piecewise function here. So now I'm approaching 2 from the left. So points to the left of 2, that's on this curve up here. So as I'm moving from the left, what are my y values doing? Well, they're going up, 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 up to 4. So we would say that the limit from the left is equal to 4. So before when we were doing limits, we didn't have the plus or minus. So how do you know if a limit actually exists? you know the limit exists if these two numbers are the same. So if the left and right hand limits are the same, then the limit exists. So since these two numbers are not the same, we would say that, so the limit as x approaches 2, without any plus or minuses here, of my function f of x does not exist, which we're going to say d and e. So if you get that the left and the right hand limits are different, then the limit does not exist. Now in our first example, since they were the same, we say that the limit as x approaches 5, without any plus or minuses, of my function 2x is equal to 10. So if you do the left and right hand limit and you get the same number, then the limit exists, and that is the limit, whatever the number was. If you get that the limit on the left and the limit on the right are different, then the limit of the actual just going to 2 of the function does not exist. So if you want to know if a function exists, you look at the left and the right hand limit. If they're the same, that's your function value, or that's your limit value. If they're different, the limit does not exist.